Hi everyone, we're going to do a video on trig for this video, and you might have already learned about trig by now, but I'm going to treat it as you know nothing about trig. So when we talk about trigonometry, it's its own branch of math. And in geometry, we deal with just a small portion of the whole idea of trigonometry, and they are um, functions. There's three that we work with. There's actually six total. One of them is sine, one of them's cosine, and one of them's tangent. And so the main idea of what we're doing with this trigonometry is we're making fractions off the sides of a right triangle. So let me go and get a picture. Well, when we did Pythagorean theorem, from there, I hope you already remember that this is the hypotenuse. That's not going to change when we do trigonometry. But what's going to be the really big difference is we're going to have two other words for the legs. Instead of calling them legs, we're going to have the word adjacent leg. We're going to just call it adjacent, and opposite leg. Okay, now, if you talk about what adjacent means, it means next to or touching. So adjacent, and there's two angles that we're going to work with, either A or C, and they're going to identify that in the problem. They're going to have told you to look at angle A, or they're going to put a number inside of angle A. But let's just say we're looking at angle A. I always tell my students to dot whatever angle that we're working with. So if I talk about angle A, the adjacent leg is the one that touches. Remember, adjacent means next to, touching. So that's the adjacent leg. Now be careful because the hypotenuse also touches, but we only use the word adjacent for the leg. And you should have already labeled the hypotenuse. I always advise my students to label the hypotenuse first. Well, that makes the other one the opposite. And these formulas, these trig formulas, like I said, they're making fractions off of this triangle. And we just need to look at what those formulas are. So we're using the words opposite, adjacent, hypotenuse. And here's a phrase that helps you. SOHCAHTOA is it's a little made up word. And I capitalized the S and the C and the T for a reason. Those stand for S for sine, C for cosine, and T for tangent. Well, you see all the letters are either OH or A, and OH and A are for these things right here. So sine would be the fraction, and it is sine of an angle. Really, you need to have an angle marking there, because depending on what kind of trig you're working is going to depend on how these problems work out. So opposite over hypotenuse, let's just write that out here. That's the formula. Cosine is A over H, so that would be adjacent over hypotenuse. And then tangent is opposite over adjacent. So when I think of trig, I think of kind of three phases to trig. So I'm going to do that for this video. Phase one of trig is where you're going to know one of the angles inside. One of the acute angles. We know the right angle, but you're going to know one of the acute angles. And you're also going to know one of the sides. And you're going to be looking for the other side. So here's an example of what that might look like. And you're actually going to be using your calculator. I'll show you the calculator buttons in a minute. And let's just say, I don't know, I'm just going to put a 20 degrees right here. Oh, sorry, let me scoot this up where y'all can see it. I apologize. So I'll put a 20 degrees right here, and I'm just going to put I don't know, 15 here, and I'm going to put an X here. So I know one of the acute angles, I know one of the sides, and I'm looking for this other side. So let's put 3. Now, I need to go ahead and make sure you understand you can't do the Pythagorean theorem here because you don't have enough numbers. And when you see an angle inside, that's almost a indication that, hey, this might be a trig problem. So let's first label. Okay, so this is the hypotenuse. All right. We're working on this angle right here. Remember I told you they're either going to tell you the angle or have a number inside. So this is the angle we're working with. So when we try to label the leg adjacent, which is a good idea to label that second, this touches that dot. So that's going to be the adjacent. That's going to be the opposite. Well, now here's the only tricky part. You have to decide which one of these three formulas is going to help you come up with a formula that will solve this. And you don't want to have too many missing parts. So we don't want to use the adjacent in our formula because we're not looking for the adjacent and we don't have a number. We need to use this hypotenuse because we have a number and we want to find this. So our two words are opposite and hypotenuse. Well, that's only going to be one of these functions and it's the sine function. So sine of 20 degrees equals x over 15 because x is the opposite. Now we're actually going to solve this for x. So we're going to multiply by 15 on both sides. And this is what we're going to put in a calculator. You do have to make sure your calculator is in degrees. And hopefully you have the kind that we use here at the school, a lot of the teachers, that looks like this. So let me zoom in to show you the buttons. And if you notice, my calculator is already in degrees. It'll say DEG right here. If it wasn't, you can hit the second button and the button right there and see how it says, sorry, I hit the wrong button. You just need to hit that button, not hit second. See how it says DEG? A lot of times these calculators will be in RAD if somebody's used it. So make sure it's in degrees. If not, just scroll over and put it in degrees. And now we're just going to enter it just like it looks on our paper. 15 times sine of 20. 15 times sine of 20. It's important to understand that it needs to be less than 15 because 15 is a hypotenuse. And if you notice, it is way less. So 5.1 is going to be that missing side. So again, that's what I call trig phase one. Now, one thing I want to make sure you understand is sometimes, let's say our formula ends up being, let's just use the same numbers, but let's just say my formula ended up setting up like this. Well, what that's going to do different is when the x is on the bottom, it's a good idea to kind of make a proportion out of it to help you figure out how to solve this. So this is actually going to be x times sine 20 equals 15. And so we're going to have to divide by sine 20. And that's going to happen every time the letter's on the bottom. So when you're in phase one, it could set up one of two ways. The letter could be on the top, then it's simple multiplication. The letter could be on the bottom. Okay, phase two. All right, phase two is a little bit different in the fact that what you're going to know, you will know 2 or 3 sides, and you probably won't know anything about the angles. Won't know angles probably, and you will just make fractions. I think this is probably the simplest of the phases. You're just taking a triangle and making, oh y'all, I'm so sorry that I keep not showing this where y'all can see it. So my thing is messed up. Elmo's messed up a little bit. Let me zoom out. Okay, so phase two, you're going to know 2 or 3 sides. You won't know any of the acute angles. And you will just be making fractions. Let me just take a sample triangle and show you this. We're going to put some letters on this one, CDE. And I'm just going to put a 10, an 8, and a 6. And those numbers do make up a right triangle. And so they might say, I don't know, let's do a tangent. They might say tangent of angle E. And so what you have to do, you still have to label based on angle E in this case. So hypotenuse is going to be the biggest number here. This is the leg that touches E, so that's adjacent, and this is opposite. So tangent, remember, is O over A, or opposite over A. And so, like I said, you're just making fractions. So go get the numbers off the picture. Tangent of E will be 8 over 6. It's okay to leave fractions, but you do in a reduced fraction. So this can be divided by 2. And that will be a final answer of 4/3. And again, like I said, it's perfectly okay to leave these a fraction. Okay, last phase, phase 3. It will start like phase 2. But the only difference is you have to pick your formula or your trig function. So they're not always going to give you 3 sides. So let's look at an example of phase 3. So if I have a triangle, let me just make up another right triangle. I'm just going to make a 3, 4, 5 triangle. That's also a right triangle. Oh, no, sorry. I don't want to put the other side there. So normally when you're in this phase, you're only going to know two of the 3 sides. Although we could use Pythagorean theorem to find the 3rd side. And what's going to be different is you're going to be trying to find the angle now. Well, like I said, you're still going to dot. You're still going to label, just like we did before. But if you notice, there's no number here. And unless I did Pythagorean theorem, I'm not going to be able to get a number here. And I don't want to do the Pythagorean theorem. That's just too much extra work. So we're not going to use anything with an A in it. So we're going to have to pick out the OH function, which is the sine function. Now, here is the only difference. Sine of an angle is O over A. Well, we don't know. Let's just put the X there for the angle. We don't know the angle. All right. So when you're trying to find, so it's almost like if you could take your calculator out and just punch in some numbers from 0 to 90, what would give you this 3/5? Well, the calculator can do this for us. It's a real easy step, but it's called the inverse key or the -1 key. So what you do is you take your calculator. I'll show you where the buttons are for this. Let me zoom back in for it. And again, it depends, you might be using cosine or tangent, depending on what your picture looks like. So you're going to take the second key, and then here's the trig buttons, sine, cosine, tangent. We used them a minute ago. So now you're going to take whatever function you have, could be any of them, any of the 3, and see how it's different now because it puts up that -1 key. And then when you hit, oh, sorry, you don't want to hit enter without putting in the fraction. So second sine, and the fraction you can put in just 3 divide by. You don't have to use the fraction button. Just 3 divided by 5 is fine. And it's going to be an acute number, right? And so we're going to round that to 37 degrees. So it was 36.8. Excuse me. We're going to round that to 37. Now watch what happens if I do this in the forward direction. Like I said, I can take the sine of 37 and I better get the fraction 3/5. So 0.6018, 3 divided by 5 is 0.6. Now it's off just a little because we rounded. So that's why it's not exact. But that makes me feel good about this answer. And so again, that's phase 3. You're using the kind of process of making the fractions in phase 2, but you have to pick out the right trig function. And then don't forget anytime you're looking for an angle, you are using the -1 key. Okay, I hope this reinforced your knowledge of trig. Please get with your geometry teachers if you're having any trouble with trig, or come see me. You can see me, Coach Hall, or Coach Monero before the leap, so you'll know how to do this trig. All right, guys. See you later.